Hello everyone, welcome to this YouTube channel Programming with DP Wala. Let's start the day with the problem of the day from the LeetCode. So today we'll be discussing this problem minimum deletions to make string balance. Even though the problem seems to be very easy and it's easy as well, but it's good to attempt the problem in different manners. Means here the problem can be easily solved using stack or basic string implementation, but here you can even use DP as well. So it's a good practice to get hands on writing the recursive DP whenever you're trying to implement a problem on for that. So I think this week is going to be a DP one because yesterday also the question came from DP. So it's good to practice. So let's discuss that approach, the DP approach, how to approach this problem using that. So here in this problem we are given a string s consisting of characters a and b only. uh, we can delete any number of characters in s to make s balanced, and here they have mentioned that s is balanced if uh, I is less than j and s of I is b and s of j is a. Means they are trying to say that whenever we encounter any b before a, means it's like here you can see b is here, a is here, so then we need to delete a character. We don't want such a combination in our entire string. Means be a combination should not be there. So be a combination in the sense here is the b, even this a as well, so this type of combination will not be there, and we need to return the string without that, and we need to return the minimum number of deletion that we need to make that string balance. So here let's take this example only: a b a b a b b a b. So the first intuition that comes to our mind after seeing this balance thing is that whenever you see any balance parenthesis type of thing or balanced keyword and it's like that, so then you need to use a stack or think in terms of stack. So this is the best way to solve that problem using stack. So but here we will be discussing the dynamic programming problem. So how to get a intuition behind it is that here you can see that minimum number of deletion they uh, written. So it's like that whenever the minimum and maximum kind of things come and you want like you are having a two choice at particular point whether to delete a particular character or not, then you can even think in terms of DP. So here let's start with this index. So we are at a. So what we are doing, we will be traversing to this string and we will be maintaining a b state, means a state of b, which will be storing whether we have encountered a b earlier or not, means is there a b present before a or not. So in our DP recursive function, we will be having one more state that is b state. So its value is either 0 or 1. 0, whenever it is 0, it means that no b has came before that interval, and whenever it is 1 means it's like that we have b currently going on, means we have encountered b before a. So whenever we are at a, our b currently we are at 0 index and our b state is 0. So here we can simply see that there is no b encountered before a, so no need to do anything, just move on. See, still our b state is 0 as we haven't encountered any b earlier. Similar for this, nothing is there, just move on. So now here here it's like that with the current character is b and our b state is 0. Means what here we are trying to say that uh, we encountered the b state, correct? So here we are having a two choices. In the question, if you see, they have mentioned that we don't want B at the start and after B we don't want A. Means like B A combination should not be there. As we encounter B, so here we have two choices. either to count it as a deletion here, means delete it and move on to next character with the b state as 0. Or what you can do, you can wait for something else, like let's wait for a to come after this, and at that time delete it. So move with b state as 0, b state at 1. So here the two choices are like delete a character and move with the b state 0. Here one more choice, that is move with the b state 1 and don't delete it. Let's wait for the uh, a to come, and we will be calling the recursive function for both this case, and we'll be storing a minimum of it, because we don't know that which one will give us the minimum value, either this one or this one, right? So let's move on. Let's say we have taken this b earlier, right? Means as b state is 1, because we already encountered a b earlier, so we are at a, means yeah, a current character is a, and we have already encountered b earlier, means we need to perform a deletion here, so we will be deleting a from here. So now whenever we are calling a recursive function, our b state is still 1. The reason behind it is that we have encountered a, but we still have b present earlier, right? So let's move on to the next character. B is present, nothing to do, just move on, because no need to deletion. Same thing, same kind of thing here. It's two choices. Two choices. Now here is the catch. When we are at A, so we'll be checking that whether our character is A. Yes, yeah, A. Whether we have encountered any B earlier. Yes, we have encountered B earlier. Means this is the case of BA that they have mentioned in question. So we need to perform one deletion. So we'll be deleting it. Similarly, we will be going at this B. It's the only B, no other, no A, and still having two choices. So, but as we don't have A afterwards, we don't need to delete it. So we simply have a count of two deletions and we'll be returning two. So here you can see they have written two. So here, whenever you are thinking in terms of dynamic programming, so let's consider what states are changing here. So here our index is moving in this direction, so I will be changing. Here I am also maintaining a b state, whether we encountered any b earlier previous to a or not. So that value is just nothing but a boolean 0 or 1, true or false. So it's so our dp will be of max length of this string, let's say n, and the state is nothing but there are only two states. So whenever, if you're thinking that this is too complex, no, n cross 2 is asymptotically equal to n only. It's O of n solution only. But as here we are writing a recursive solution where there will be a stack space as well, so of n time complexity of n space. So just whenever you're writing a DP solution, try to write conditions where we need to call the recursive function. So here it's like that. You are at A and your base state is 1. Three conditions are here important, right? You encounter A and B state is 1. One means delete it. Second second condition is that we don't encounter A but our B is 1. So just move to the next index, wait for the A to come. Third condition is that we have encountered A but B is 0, means no B has encountered till before A. Means don't no need to do anything, just move with the B state 0 and move to the next index. And the last one, I call it as like when you are at B here. I mentioned that here we are doing this, but it's like that whenever you are at B, you don't know that whether you will be encountering A further or not. So let's assume that don't delete it and move on, or delete it and move on. So we will be storing a minimum of that. So two condition, minimum of this two, as we have discussed. This two, sorry. So these conditions are there. You need to write the condition for this. If you write recursive solution, then just memorize it with the DP table. You are done with your solution. So this is the implementation that I have done. I've created uh, one 10 to the 5 cross 2 DP. You can see that the at max string length is 10 to the 5. So I have created 10 to the 5 plus 1 cross 2 size DP. 2 as its states are only 0 and 1. That's why. Our base condition is this, that whenever we travel to the entire string, we traverse over entire string, just return 0. Then there is the memoization condition, that whenever the value is already visited, means I have filled my DP table with -1. If it's not -1, means it has already been calculated, so no need to calculate again, just return that value. Then the four condition that I have mentioned. If we encounter A at the current index and B state is 1, means we already encountered B earlier, previous to A. So just delete it, move on to next index with B state as 1. Right? B as B, we encountered B earlier. If current element is not A, but our B state is still 1. So just move on to next index with B state as 1. If current element is A, but we haven't encountered any B earlier, so just move on to the next index. No need to do anything with the B state 0. But if we encounter B, so we have two choices, either to delete that and put your B state as 0, here you can see, or move on with the B state as 1 and wait for some LA to come and delete it, right? So these are the four conditions that you need to write, and this is the recursive solution for it: index, B state, and string. So if you want to understand the stack implementation, I think that it's a quite intuitive solution. Just traverse over the from in the reverse order. Whenever you encounter any A or string, your stack is empty, just put that element. And let's say if your stack top is A and currently you have encountered B. Let's say here our stack consists of B and A. Whenever you come at this B, your current element is B and your stack top is A, means this is the condition of BA. Just remove it from stack, and you will be, whenever you are removing the element from the stack, just increment the count, means that's the condition of BA where we need to perform deletion, and at last simply return count. So this stack question is very easy and it's quite intuitive. Here I have explained this DP solution because it's like for the ones who are want to master DP, and it's like, so this is a good problem to perform that DP uh, on this type of things, right? To get the hands on over it. So hope you like the video and hope this will be helpful to understand how to understand the states of DP and how to write a recursive solution. So thank you for that's it from my side, and all the best for future. Thank you.